All right, class. Quick reminder of where we were before. We're talking about demand and elasticity of demand. We're trying to figure out at what price we should set something by looking at demand, because someday that might be important. And we're finding the three methods for finding how a product's elastic or inelastic. And so we get with the definition. I showed you a video. Um, I showed you that visually um, how they look, an elastic versus an inelastic demand curve. This would be more of an inelastic one. Um, and then I had us watch the video, and I wanted you to come up with two ways to find elasticity. And I believe through the video, we came up with that if there's substitutes for a product, if it's a luxury or a small or large part of your income. And um, so that's one method of finding if something's elastic or not, is using those three questions. Okay. Now there's another method that I'm about to introduce to you. I'm going to start it off by showing you unit elastic. Unit elastic is a thing in between elastic and inelastic. And so what is it? It's when the percentage change in price and quantity demanded are the same. So for example, a 10% increase in price would cause exactly a 10% drop in quantity demanded. Now naturally, an increase in price would cause quantity demanded to go down. But if it's exactly the same proportion, 10%, 10%, well, that's going to be unit elastic. So a little question for you to think this through. If a 10% increase in price causes a 20% decrease in quantity demanded, would this be an example of an elastic or inelastic? So to help you think through this, go to page 121, look at the formula for a second. This is the formula right here. And so if we notice, what you're going to do is you're going to take percentage. So there's a bunch of things that step one and step two, but we're basically at step three. Percentage change in quantity demanded, percentage change in price. Divide them. So let's go back for a second. We're dealing with a 10% increase in price, a 20% decrease in quantity. So it's on the top here. On the top here, it says quantity. So that's going to be 20%. 20% by 10%. And so 20 divided by 10 is 2, right? So we're going to get an answer of 2 over here. So then we go down to step 4. It says after doing your calculations, if the final number is greater than 1, demand is elastic. If the final number is less than 1, demand is inelastic. And I'm going to tell you now, if the answer is 1, it's unit elastic. So the answer, this would be, the sample question would be an example of elastic. Because if you think about it, a small change in price created a big change in quantity demanded. And so that's elastic. Now, we've now learned our second way to find elasticity is the formula on page 121. So we've got our questions, our formula, and now we're going to get into another one. So by the way, this is going to be your homework tonight. You're going to do the backside, the 4.3 worksheet, and you're going to do those question A on page 118, 120, and 121, question B and C. So let's talk about the other way now, total revenue. We have to understand what total revenue is before we can look at the other way to find elasticity. So total revenue is a company's income from selling its products. So total revenue is the price times quantity sold. That gives you your total revenue. So let me ask you a question. Is the total revenue of a company its profits? Let's think. Revenue, does that equal profits? The answer is no. Revenue is not the same as profits, at least not in economics, in the language of economics. So profits is revenue minus your costs, just FYI. So, okay. So a total revenue test is the other method of measuring elasticity by comparing total revenues. So let's think about this for a second. I've got my hot dog stand, and I'm going to sell my hot dogs at the Milwaukee Brewers Stadium because I like the Brewers, and the price is $2.50 a hot dog, and I'm going to sell, because of how things are going that day, 100 hot dogs per day. And then, they win the game, And normally on a good day, I'm always selling 100 hot dogs per day. But today, you know what? They won a game. I'm like, sweet. I'm gonna lower my price to $2 as a celebration, and I sell 150 hot dogs more. I mean, I sell 150 hot dogs that day, so I sell 50 more than I normally would. So now, is this an example of elasticity or not? Well, we can find it using our total revenue test. So first of all, let's think about the revenue for my first day. Well, we take 100 times 250, that gives us $250 for that day on a normal day. But now after I lower the price, because they won, I get $300 because I took 2 times 150, right? So I got my two revenues. And so when you lower the price and the revenue goes up, this is an example of an elastic product because the price goes down and the revenue goes up. So let's look at a different scenario. Let's say I've got my hot dog stand, but let's say I have this other hot dog stand someplace else. Let's say this is in Chicago at Wrigley Field or something. And so I'm selling for $2, 150 hot dogs per day on a normal day, and my revenue per day would be $300, right? So let's say I decide because they're doing awesome, the Cubs are doing awesome, so I'm going to lower my price again because I have my other stadium. I found out my revenue went up when I lowered the price, so I tried again here, and this time I lower it by $1, and I sell more hot dogs, but I only sell 50 hot dogs more, and of course my revenue, I take $1 times 200, I get $200. Wait a second, my revenue went down this time. Okay, so when your price goes down and your revenue goes down, this is an example of an inelastic product. So apparently my hot dogs in Chicago are inelastic, whereas my hot dogs in Milwaukee are elastic. So now you can do your homework using the three methods of elasticity. You can use the total revenue test, as here. You can use the three questions, large private income, small private income, luxury versus necessity, substitutes, no substitutes, or the formula on page 121. So now you know the three ways to calculate, to find if something's elastic or not.